Good morning, everybody, and thank you for joining us today for the third day of the Aqua Tech Week webinar series. I'm Alex Shuretsky. I'm the digital coordinator with Annex Business Media. I'll be your moderator this week for this event. Before I introduce our speakers, I just want to take care of a few housekeeping items. First and foremost, I want to once again thank our sponsors for making this week possible. Thank you to BioRouter, Grundfos, Standard BioTools, Hudeck, Balmoral Tanks, Asahi/America, and Cascades. As always, this webinar is being recorded, and a link to the recording will be sent to all registrants 24 hours after the conclusion of the webinar. Questions for our speakers are welcome and can be submitted through the Q&A function at the bottom of your screen. Time has been reserved throughout each presentation to answer your questions. With all that out of the way, I would like to introduce our first speaker of the day, Adam Callan with Balmoral Tanks. Thank you so much for being here with us today, and with that, I'll pass it over to you for your presentation.
Good morning all. Thank you for the opportunity to present to yourselves. I'm here to talk to you about Balmoral tanks and what we offer in terms of the blue tank, which is our bolted steel tanks for use in the RAS sector. So a little bit about the presentation and what we will talk to you about. We'll go through the design of our tanks, so the principles and considerations that are taken into account for the design of our bolted steel tanks. The manufacturing process, so you'll see a little in-depth video of our brand new state-of-the-art epoxy and glass coating facility here in the UK. And we'll also talk about the quality control standards that we have in place that allow us to deliver the product to yourselves. The coating options, so as I briefly mentioned there, we have our epoxy coated steel line, which is what the blue tank is branded on. But we also offer the vitreous enamel glass fused to steel tank as well. The installation of said tanks, there's different types of installations, which some of you may be aware of and some of you may not be. So we'll have a little chat about them and how they could benefit you and benefit your project. And ultimately, what are the benefits and why would you want a bolted steel tank over what you currently buy? So we'll just chat a little bit about them. So just to start the presentation on the design process. So Balmoral tanks, all our products are designed in line with AWWA or Eurocode. So that covers wind, snow, seismic, hoop and axial, and is delivered and signed off by an in-house chartered Balmoral engineer. So all our designs are substantiated against specific project parameters. So whether that be if you have the high seismic requirement, if you have a high wind requirement, a high snow, it's all delivered to suit that client and that system's requirements. All our drawings or our general arrangement drawings are provided in 2D and AutoCAD, and we have also recently made the jump across to 3D BIM modeling. So the benefit of the 3D BIM modeling is it allows us to see the integration and the interface between the tanks and the pipework and the other systems that would run around the tank. So ultimately eliminating any clashes of pipework, clashes of steelwork, clashes of bridge structures, etc., to ensure that when the tank is delivered to site, there'll be no hiccups in terms of that delivery. All our drawings are provided with a QR code, so it's a unique QR code to your project. So it reserves the link, reserves the right of sending multiple drawings over emails, which are large and could eat up your inbox data. So it's just a little 2D drawing that has a QR code that wherever you are in the world or wherever you're at home, etc., you can scan the QR code and it will automatically bring up on your phone or your system a GA of that tank. The ancillary equipment we provide, so we can bolt on to the edge of these tank overflow boxes for dead fish, walkways, feed systems, etc. All that is taken into account within our structural analysis. So our chartered structural engineer can ensure that the tank is designed to support said structures, and again ensure that there's no issues when that delivery comes to site. So we can also provide netting systems as covers for the tanks. So these obviously transfer tension through the tank or through the angle of the tank. So with what we provide, the top angle, the stiffening of that can be increased to allow for the netting to be supplied. And again, early doors, ensuring that there's no issues when that gets to site and is ultimately installed. So again, we have multiple base to wall fixing options. What we call is a flat to base, which is predominantly used in Europe, is just a bolt straight through to a concrete base. So there's no need for embedded starter rings. There's no need for complex concrete works. It can just be a smooth, flat concrete base. But then we do also, where seismic parameters are taken into account, we are also able to supply embedded starter rings. So that takes away the need for the extra stiffening on the bottom to ensure that the seismic design is met. So I'll just give you, before we go into the manufacturing process, I'll just share with you a quick brief video. As this is a state-of-the-art facility that was built in 2018, dedicated to our blue tank epoxy coated steel line. And we did then extend that in 2020 with the glass line. Ultimately, it's around a $30 to $35 million investment for the full factory. So in terms of the manufacturing, from what you've seen there, so the manufacturing is taken in both standards of ISO 9001. So Balmoral are accredited to ISO 9001 and 14001. So that ensures that there's traceability and compliance on all our procedures. So if you wanted to require to audit Balmoral, all our manufacturing processes from procurement to the manufacturing is all governed by those ISO procedures. So the coating lines that you've seen there, again, are state of the art, are factory controlled. So the product is delivered in line with what we state are our manufacturing specifications. So by that, there's no hand painting, there's no layer painting of the epoxy. It's all governed by the machines that are driven in the factory. So all the fabrication work, so any cutouts, any connection requirements, again, is all done prior to the coating. So we ensure that there's 100% coverage of the nozzle of the manway or whatever that would be, it ensures that there's 100% coverage of that specific part of the panel. So we can deliver, so QITP is quality inspection and test plans. So that can work from goods inwards right through to dispatch. So you're able to see, so from the start of the project, what's gone on right through to when that's ready to dispatch to yourselves. So we also can then guarantee a 0 defects coating standard. So that's governed by, we do multiple tests on completion of the manufacturing. That's coating thickness tests to ensure that they meet the specification that we've sold the tank based on. And also what we call a holiday/swab test. That would either be an 1100 volt or 1500 volt electricity test to ensure that there's no pinholes within the coated steel. So in terms of the coating options, we have 2 products. That is the fusion bonded epoxy, which is what the blue tank is branded on. And we also have the vitreous enameled, which is the glass fused to steel coating. So as you've seen in the video there, the epoxy coating tank systems they're supplied with powder and then is cross-linked in the process ovens to provide the finished surface. So what we mean by that is the plate has a positive charge, the spray has a negative charge, so that completely encapsulates the whole of the steel process through the system. In terms of the glass product, so the annealing process, by that we mean, so we heat the glass to a certain temperature to allow we heat the steel to a certain temperature to allow the glass to fuse into the steel. So by doing it that way, you can lose 20 to 30% of your structural substrate strength. So that means that in terms of using a glass tank over an epoxy tank, you may be using thicker plates in the finished design. So for argument's sake, for a larger RAS tank, whereas an epoxy tank may use a 4, 5, and a 6 mil plate, it's very likely that a glass tank may use a 6, a 7, and an 8 mil plate due to that strength loss. So again, we test our products in similar ways, as I mentioned earlier. We do an adhesion test, a salt spray test, an impact resistance test, a holiday test, which is the swab test, the electric volts, an abrasion, weathering, and chemical resistance test. And both products do provide excellent results in all areas. In terms of a key factor at the moment in the world is energy and carbon footprint reduction. So in terms of the products that we offer, epoxy uses far less energy than what it does to produce a glass panel. And also in terms of the strength being retained with an epoxy, it also usually leads to a much less weighted tank than what a glass would, which provides you with lesser shipping weights and easier to handle on site. So in terms of the installation techniques, there are 2 standard used. Many of you might be aware of what's called the jack build, and we also have what's called the stack build. So what are these and which one would be preferable for your project? So the jack system is a system that we use where you build everything in reverse. So if you can imagine these tanks turn up like a big Lego or Meccano set, or IKEA, if many of you shop in IKEA. So what then happens is we build the top of the tank first. So usually the roof and the top ring, and we then mechanically or hydraulically with the jacks lift and then install the next ring. So all works are undertaken on ground level. There's no work in the height, and it allows for speed of build with an experienced team, each knowing what their role is in that install. So stack build is the opposite of a jack build, and obviously uses plant and scaffold, fixed scaffold systems, or aluminium tower scaffold systems. So the difference being in that is that you can build tanks up to 2.4 meters high, so off the floor. So it's, and as you get higher, obviously you get more or greater away from the floor. So the difference again, the benefit of using jacking above the stack building, which we understand needs to be done in some areas, is that it's all done at ground level. So there's no lifting of heavy sheets. There's no lifting of heavy nozzles to install at high level. Everything can be done at ground level. So again, in terms of the bases that we talked a little bit about earlier, so all bases should be flat, circumferentially level, and they can all slope away from the edge of the tank into a center point if you needed a discharge for a drain or a similar option. All we ask is that there's a 500 mil level section just before your slope starts, so that we could sit the jacks on a level footing in order for them to operate correctly. So again, there's several base fixing options. What we spoke about earlier, which is the flat down, which is the bolt straight onto a concrete base, and the embedded starter, which is far more predominantly used in high seismic areas. So we would advise that you speak to your tank partner to ensure that you have the most appropriate solution that's given to you. So in terms of the tanks themselves and the build, things to consider when you're building these is that they are sectional. So as we mentioned, they are very much like an IKEA flat pack in how they come delivered. So they are bolted together using the lap joint principle, which is that the joints overlap each other in 4 corners. The tank, they're then sealed together using a mastic seal. So the mastic seal goes right the way around them. We provide low-level manways. This gives us access into the tank and egress out of the tank on completion of the build. It also provides you with safe access and egress should you ever need to go in and survey the tanks or carry out any maintenance works. You're not going up and over the tanks. There's a little hinged doorway which you can unbolt, and access can be gained through that. So we understand that each project is different and has a specific pipework profile. So again, as we mentioned earlier in the presentation, that can usually be designed out to ensure that when the guys are building, there will be no clashes on site, so it allows for a quick and lean and smooth build process. So in terms of the coating, many people, if they've used glass tanks in the past, will know that they spoil around the bolt holes during installation. This is technically because that you cannot 100% guarantee coverage of the bolt holes because of the way the manufacturing process is carried out. So what tends to then happen with glass tanks is that they will start to corrode and rust. And unfortunately, you get into an argument with your tank supplier or the manufacturer, and there's never really an easy solution. With the epoxy, that's different. We can guarantee 100% coverage of the bolt holes because of the positive and negative charge of how the epoxy tank, the epoxy paint is applied to the tank panel. So again, I mentioned what we do in the factory in terms of testing. So we test to 11 or 1500 volts, depending on the product that you've chosen. But then what we also carry out is a 90-volt swab test on site. And the reason for carrying that out is, again, is just to ensure that during the installation phase, there has been no damage to the coating. So there's been no pinhole chips for where someone's walked past and accidentally clipped up against the tank. So that again ensures that there's no way back for corrosion, etc., back to the substrate steel. So in terms of the product benefits, so over what you may be purchasing at the moment, what are the key drivers that we would say that Balmoral's Blue Tank is potentially the correct solution for you? So again, code design. So it's important for your project that we design to a worldwide code, whether that be Eurocode or AWWA, which is used far more in North and South America. It also gives you the asset insurance that is designed to that code. So calculations are also provided and stamped to ensure that you can use that as part of your documentation pack. In terms of the supply, it's modular. Again, I refer back to the IKEA. It's a flat pack, so it's very easy for us to put multiple sheets and connections into a container, so it's low shipping cost incurred for that. The factory control coating application, so again, it's governed by our QA hierarchy, our ISO 9001 approvals, so we have to adhere to those approvals. In terms of the installation, it's quick. It's very surprising how when people see these tanks, how quick they're built. From when you can be looking at it one day with nothing on the ground to the day after, you may have 2 or 3 rings of a tank high, and it's impressive to watch the build procedure be undertaken. The design life of our tanks are 39 years. That's based on empirical data of past product installations, and they range from aggressive environments such as anaerobic digestion, sludge environments. So, you know, we have the experience behind us to know that these tanks are certainly the Blue Tank, the epoxy coated tank, is the product for this market. And zero maintenance principles. There are no moving parts. once it's built and signed off, and you get the full corrosion protection of the coating that has been chosen. Thanks all for your time, and I'm happy to answer any questions that anyone may have.
Awesome. Thank you so much for that great presentation, Adam. I'm not seeing any questions just yet. So we'll give people a minute or two to submit them there if they have any. I was just going to ask, is there something you want people to take away? What's the main takeaway from the presentation, or something you want people to leave this with?
I think that the main thing that we want is the brand of Blue Tank. You know, the epoxy coated steel tank is being widely considered in many projects, but we still feel that there's more opportunities for us to engage with landowners, with suppliers, in order to further understand what our product is about and what the technology that we use. We're aware that there's been issues in the past with glass fused to steel tanks, but that's not what we are promoting. The Blue Tank is an epoxy coated steel tank, which we believe is a far superior product because of the coating system that we use and the way that we can ensure the 100% coverage of that, to ensure that there's no corrosion.
Perfect. That's beautiful. So do you find that you typically have problems commercializing the product then? Is that?
No, it's not so much commercializing it. It's just getting it out to the market. I think Balmoral, we really started to look into the RAS market probably 18 months, 24 months ago. So it's a market that we see great progress in terms of that. We've had some landmark projects that we've now delivered, and so we are seeing a keen uptake. It's usually around the 12-month cycle from when we engage with people to then when we usually see an end product, an order come through the door. But you know, we're getting reference projects on the ground, which is obviously always a good thing for people to then believe in the product as well.
Beautiful. Awesome. Thank you. I got one question here asking if you have any pictures of finished product. I figured they can probably reach out to you for that.
Yes, yeah, they're welcome. Yeah, we've got we can supply multiple case studies. We have some pictures of the flagship project we've done in Holland. I can't say the name, but there are some pictures that we've done for one of the larger companies in Holland. So we can share you that you could see what that RAS farm looks like with the Balmoral. I think there's 18 Balmoral tanks on there, which make up that farm. So I'm happy to share that picture. That's not a problem.
Awesome. I was going to say, could you maybe then put your contact information just into the chat while these other questions pile in here?
Yes, of course I can. Yeah, let me just do that.
Yeah, for sure. There's a lot of people thanking you for the presentation as well, so great job.
No problem at all. So there you go. You should see my my emails just popped up there now.
Perfect. I have another one here. What is the minimum size tank that you can manufacture?
So the minimum that we can do in terms of diameter is 3.1 meters diameter. So there's not so much in terms of height. It can be anything. So, you know, so about 3.1 is the smallest in the diameter that we can offer. And then we can range up to 10,000 cube. So in terms of the largest, it can be realistically as big as you want it to go.
Perfect. Okay. Awesome. Another one here. Thank you for the presentation. Have you had any issues when trying to make new perforations to the tank for new pipes, for example?
So in terms of the glass, it's difficult. So just going, I take it they've had some issues maybe in the past with glass because of the fragility of glass. Once you cut around it, you obviously can crack the glass, and you ultimately then repair that with epoxy paint. With the Blue Tank brand, it's exactly the same. So you would cut it, you would then coat it on site. So that would be hand applied. So you'd ensure that you've covered the rest of the hole where you've cut in your pipe perforations. So it's a standard job that we do in the UK regularly on multiple jobs, and yeah, there's no issue in doing it. So if they want to reach out, if they've got a project where they need to look at that, I'm happy to offer some advice on that and guidance on what they can do.
Perfect. Awesome. Thank you. Another one here. Can this material of construction be fit to be implemented in saltwater?
Yes.
Yeah. Okay, perfect. Well, that looks like it's all the questions that we have for today. I just want to say thank you once again for being here and for presenting for us today. So that is all the time we have for the first speaker. Thank you very much, Adam, for your great presentation.